All right, new unit, statistics, 6.1. So we're going to talk about data and data gathering. So an overview of statistics in this lesson, we are going to define statistics. We're going to distinguish between what is a population and a sample, and we're going to distinguish between sampling techniques. So, what is statistics? Well, it's the science of collecting info information, organizing the data, analyzing and interpreting the data. So collecting information and then organizing, analyzing, and interpreting the data gathered. Now, so data. It consists of information coming from observations, counts, measurements, or responses to surveys or questions. Now there's two types of data we'll be talking about. One is population and one is sample. As always, if you need to hit pause anytime, go ahead and do so. So, data sets. First off, we have population. It's a collection of all outcomes, keyword here, all, outcomes, responses, measurements, or counts that are of interest. Then there's a sample. Well, a sample is just a subset of the population. And we also have what's called a census. And that's all individuals in a population are surveyed. Again, all. So you might have heard how the United States takes a census every 10 years, see who's living here. They're trying to get all individuals. Okay, so sample versus population. If we were interested in the opinion of having an A day or a B day tomorrow, and we surveyed every teacher, every student, and every staff member at Summit, that is an example of a population. Again, the key word being every or all. But if we randomly selected 19 members from Summit, or 50 or 75 or whatever, that would be a sample. Just a subset of that population. So let's determine what these are. And go ahead and hit pause if you want to try to just guess at these first. Then hit play and see what they are. Okay, so the age of all teachers at Summit, keyword all, so that's going to be population. The weight of 200 employees at McDonald's, that's going to be a sample. Now, you could say if it was, one McDonald's that had 200 employees, a specific McDonald's and every employee there, then it would be a population. But this seems like it's probably just out of all McDonald's, 200 people. The salary of each player in the MLB, Major League Baseball, well, that's a population. Again, the key word here is each. Each, every, all. The average speed. As soon as you say average, you know you're just taking some. And then also, it says just driving at this specific time. So you're just taking some of them, sample. And then the heights of 50 basketball players in the NBA, well, that's a sample because there's 150 players in the NBA. All right. Practice. Identify the population and the sample. So a survey of 546 women found that more than 56% are the primary investor in their household. So, what is the population? Well, for this, the population is the 546 women. And then 56%, that's of women surveyed. So the sample is the 546 women. Sorry, I meant to put just women. And this is, the sample is the 546 women. So again, the population is all women, and they only asked, though, 546 of them. And you just got to remember that about 56% was just of those women, not all women. Okay, studied 372 ladybugs in Missouri. Well, here's our population. And the sample was 372 ladybugs in Missouri. All right. Sampling techniques. Now, how do you sample a population? There are many different methods. So first off, we're going to talk about what's called simple random sample. Which we will abbreviate as SRS. So each individual in the population has an equal chance of being selected. So that's the classic every name in a hat. And pick a certain number. Again, you could do it more modern than a hat. If we were doing everybody at Summit, you could have the database of every name here at Summit and have the computer randomly pick. But that's just a random sample. Okay. Next is a self-selected sample. Okay? Individuals volunteer to be part of the sample. The key word is volunteer. Okay? So, again, that's like if, your cable TV people that you have a contract with ask you to respond to a survey about their services. Well, not everyone is going to reply, and so therefore the ones who do reply are giving information. But the problem with that here is it tends to create bias. When someone volunteers, because they care about the situation one way or the other, they either feel very strongly for or against, and so it can create a bias towards that. Next is a convenience sample. Individuals are selected based on how accessible they are. So that would be like standing at the entrance to a building. You might see people with clipboards outside Walmart or outside a library very often. And they'll ask you as you walk up a question, are you a registered voter? I'd like to ask you some questions. Now, these two get confused sometimes because the people who say yes are kind of the same as the self-selected, but the difference is you're not asking everyone who goes to that library to choose. You're standing there and asking the ones you run into right then and there that day, or those hours that you're there. So there is some similarities between self-selected and convenience, but there is a difference also. Next is a systematic sample. Members of the sample are chosen according to a rule, such as every nth individual in the population. So every fifth person, every seventh person. Okay? Or at a company, you might take on the assembly line, every 7 watches, or whatever's being made there, and randomly test them. Okay? But the systematic part is that it's the same number every time. Next is a stratified sample. And the population is divided into groups. That's another word for strata. Strata means layers or groups. And individuals from each group are selected, typically through a random sample of each group. So, for this case, you might, if you were doing a survey at Summit by class, and I mean freshman, sophomore, junior, senior. Okay? And then randomly choosing from each of those. That would be a stratified sample. And then last but not least is a cluster sample. Okay? Again, it's divided up into groups. Some of the groups are randomly selected, and either all the individuals in these selected groups are selected, or just some of them, typically through a random sample. So this is where we talk about cluster, like if you were in a school district and you wanted to base it on attendance area, by elementary school. So if Rockwood was going to do a survey that was a cluster sample, they might do a random selection of families based on attendance to an elementary school, because those people are all in the same neighborhood area. Okay, beware. All the sampling techniques will produce data, but not all samples are representative of the population. Some are biased and lead inaccurate conclusions. We already mentioned that on one of them. So, let's try to see what we learned. Again, if you want to hit pause and try to guess at these first, go ahead. Which sampling method was utilized and why? Student organization looking to get signatures for a petition camp out in front of class of 1950 lecture hall. Well, that's going to be convenience. They're just trying to get whoever walks into this building. B, select 3 students from a class to receive ice cream by putting all students' names in a hat and picking out 3 names randomly. Well, that's going to be a simple random sample. C, select 3 female students and 3 male students to receive ice cream by putting all men's names in a hat and all women's names in a hat and picking out 3 from each hat. Well, that's stratified. So stratified, like I said before, could be based on class, freshman, sophomore, junior, senior, or grouping male, female. Just another way of doing it. But you're breaking the population into groups and then randomly selecting. In fall 1995, the BBC requested viewers to call in and indicate their favorite poem. Well, that's going to be self-selected because only the ones who call in, who choose to do it, are participating. Divide the class into 4 groups. Well, right there, I already used that example, so you know that's going to be stratified. And then Priceline.com randomly emails their customers. Again, they're being asked. If they choose to do it, they are self-selecting. All right. Let's say this is 4, 8, 12, 16, 20, 24 test scores. So maybe for one class. These are the test scores in one class of mine on this unit. Okay? Well, there are 2 types of means. There's the population mean and the sample mean. Okay? So the population mean is if we add all of these up and divide by 24. Well, we'll get 78.625. 79% rounded. Okay, so this is where you can venture different from the notes if you want to. It says pick any 8 scores and then add them up and divide by 8. All right? So if you want to pick 8 right now and hit pause and find your own average, that's fine. I'm going to pick some random ones right now. I'm going to pick 55, 88, 98, 71, 46, 66, 84, and 81. Okay, so I'm going to add those up and divide by 8. When I do that, I get 73.625. And I can call that a convenient sample because I randomly chose from the ones that showed up, so to speak. Now, pick every 3 scores starting at the top left-hand corner. Okay? Well, in this case, I'm going to start at the top and go 1, 2, 3. 1, 2, 3. 1, 2, 3. And you can see where this is going to go. It's basically going to be these columns right here. And notice I have 8. Now if I add those up and divide by 8, I will get 80.625. And that's systematic because I went every 3rd number. Okay? Now, the last method, I'm going to show you how to use a calculator for this. Whoops. Not mean that. Why is it doing that? Now notice what it says. It says number the boxes 1 to 24 and use a random generator. Now, it doesn't matter how you number them. You could go 1, 2, so forth, or you go 2, 3, 4, 5, whatever you want to do. You choose. And you're going to do this on your own. So I'm going to do it this way. Okay, there's my 24 boxes. Again, if you want to number them 1 through 6 across the top, and then 7 through 12, that's fine. Just more randomness to it. Now, what you're going to do is you're going to take your calculator, and I want to point out there's an error, the typo in the instructions. It says starting number, ending number. There should be another comma here, and then put number of items. So how many you want to select? Or we're going to put 8. So there should actually be 3 numbers in here. So that's an error. Sorry about that. So you're going to take your calculator and turn it on, and you're going to go to Math, Probability, number 5. And you're going to say 1, comma, 24, comma, 8. Lowest number, highest number, and how many we want to choose. And there's our numbers. 23, 6, 9, 1, 23, 1, and 14. Now here's the problem. Notice how you have some repeats? Often we don't want to choose one more than another. So actually, we're going to do this a little bit differently. I'm glad it actually came up. I wasn't guaranteed for it to happen. You want to go to Math, but instead of number 5, go down here to number 8. And then do the same thing. 1, comma, 24, comma, 8. Now we have a guarantee we'll have no... Yeah, that didn't work. Must have put something in wrong. Okay, so I just found out, unfortunately, on this calculator, the 84 Plus, it does not allow you to pick how many to put in. So you can only say from 1 to 24, and it's actually going to give you more than 8. It's going to give you all 24 just randomized. So it's up to you. If you want to do 5 and do it a couple times without any repeats, or here if you want to just take the the first 8, that's fine. So I'm going to do that. I'm going to take number 1, 19, 20, 10, 21, 1, 2, 3, 4, 5. I need 3 more. So 6, 18, and 24. That's still random. So I'm going to go back up to my list. And again, what numbers am I picking? I'm picking 1, 11, 20, 10, 21, 6, 18, and 24. Well, what numbers do those represent? So 46, 85, 20 is 99, 10 is 72, 21 is 70, 6 is 72, 18 is 79, and 24 is 99. So, real quickly, I'm going to put these in my calculator. That's 7 and 99. Wait a minute, number 20 was not 99, was it? My bad writing. Oh, it was. Okay. So, I'm going to add those up on the calculator. And when I add those up and divide by 8, I get 77.875. And that was simple random sampling. So I just had the calculator pick 8 random numbers. And that's it.